let's talk about first about the history of why this tool was created. Uh, you all know that this is something, the tool that can be used with the Pllamer. Pllamer and Llama are the virtual labs for us, just to make it possible for training and any other activities around the virtual machines. Uh, and all that you can create inside of the Pllamer or Llama can be created in two ways. The first way would be by just launching.
Maciej, do you
Yeah.
presenting something?
Sorry. See, yeah. Sorry.
And I don't see that the recording started, so.
Because I'm recording that on my OBS tool,
Okay.
and I will just share it in a few.
Just the recording in Teams also works very well, I think.
But it has low quality.
Ah,
I
why?
wanted to
No.
be
Okay.
4K, you know, high resolution, high definition. I'm just kidding. I'll share it with you later after I've made some maybe cleaning or doing some activities around that. Okay, can you see my screen right now?
Yes.
Okay,
Yes.
perfect. So there are two ways of creating anything inside of the OpenStack. The first one is by creating manual. I mean, you can create a launch instance, select the details like source, the image that you would like to start with, choosing a flavor, setting a networks, defining which ports are going to be assigned, uh, using security groups, making keys, additional configuration, etc., etc. So there are plenty of ways of doing that. You can also create that with the use of the heat templates. Heat templates in orchestration are the files that allows you to have all configs inside of the one file from which everything is gonna be spawned, starting from networks, subnets, ports, any kind of additional information. And to be honest, the first time when I started to do anything in OpenStack, it was a nightmare for me because the simple setup of 3 or 4 SRs connected to each other with a simple topology like one-to-one and additional NFMP server took me like a few days just to make it proper and working. So I thought to myself, it's a nightmare. No one's gonna use it, and I think it's not something that gonna be needed here because we want to have solutions that are fast, are give you a possibility to adjust and use something that is non-standard. So I came up with an idea just to create a Pllamer. Pllamer is not something very innovative. I mean, it's you probably know some sort of tools like EVE-NG or GNS. Those are the ones that gives a standard for that kind of activities. I've tried to create a tool that will allow you to uh, have something uh, easy and something that you can draw uh, some sort of topology inside of your projects and gives you opportunity to not to think how much do I need to change my configuration to make it work. So the Pllamer is just a plain simple worksheet which you have the tool that you can move whatever you want. Uh, the first and the thing that you need to remember is it's not live for now. It's just a drawing of the topology, and after you save that configuration, from this point you can start spawning that in OpenStack. Uh, okay, so let's start with the very simple setup, just 2 nodes. Uh, I recommend to use the jump host. At every end of your configuration, just place the jump host, and this will be a node which is predefined with some setup. It will be using a proper image which contains some basic tools and basic setup. As well, it's just gonna get proper IP address from the subnet that's gonna be created. What's the BOFnet? Creating this Pllamer, I've chosen some couple of elements that are static and they're something I would call uh, key elements of the Pllamer. The first one is the BOF network. Every single node that you're gonna put inside of the Pllamer will be attached to BOF network. Why did I do that? Because I have created Pllamer that is Nokia oriented, and due to the documentation of our vSIMs and all the simulators, they are created on the virtual machine inside, and they have static association and assignment to the port. So the first port on that VM that's going to be created is always a BOF port. There, no matter how much and how many we will create, every single one, the first port connected is going to be above network. Second and third, it depends on the chassis, but the second is always the fabric, and then they are starting with the ports to the cards and MDAs and the port itself. So this is something that I've tried to get with. So ports, the nodes that are placed here, they're always connected to the BOF. So no matter if you don't see in a network, it doesn't mean it not exist. It just it is as a default to not make you wanna think about this. You just place it here, put the node, and the management is there for you already. Uh, about the jump host, it contains some few elements that define environment setups just for you to make it easier to use. And as you can see, it's IP address of 192.168.0.250. What else? The jump host will automatically get corporate share IP address. This is IP address which can be reached from your laptop connected through the VPN or inside of the office, and you'll be able to reach that from any Nokia network point. Okay, we've got 2 points, 2 nodes. So take a look on what we can do with them. Uh, as you can see, the naming convention is quite simple, right? It's just R, it's a shortcut from the router, uh, and number of the ID of the element. This ID of the element goes directly to the BOF network IP address that's going to be assigned. So if you have R1 and R2, R1 IP address will be 1 and R2 will be 2. Uh, in this edit window, you can change the flavor. Those are the flavors inside of the OpenStack. For now they're static, but I'm thinking of making that more automated and being taken from the OpenStack itself. But for now it's just a static. Same for the images. You can choose whatever image you would like. We are starting as a default with the Nokia images, but there is also opportunity just to use the VSDs, VSCs of the Nuage and SGs. You can change it to something else. So it's only you to decide what you like to use. There are some Junipers and Cisco's, but I'll just make some comments on those in a while. Okay. So let's stay with this one. Chassis. Those are the chassis types that are available for that version. Changing the image and choosing proper version will influence the possibilities. Those are based on the documentation that our company is releasing with the documents for the vSIMs. Okay, so and here is information about the ports. But,
May I have a short question
yeah, sure.
regarding flavor and a short description of the rules, when to use large, when to use some small flavor?
You know what? This depends on the documentation. Let me just open. Okay, and let's take a look on this. This is documentation that if you want to know anything more about our simulators or 7750 or 7950, you just need to download this document. This is the vSIM installation and setup guide, and in which you can see that this is the concept right here, but host machine requirements. Take a look on that. Depending on on the cards and on the chassis, you're supposed to use some sort of gigabytes of RAM and CPU. The default is 4 or 6. It depends on what you're going to choose. So there are no description inside of the Pllamer, so you need to go into the Pllamer inside and check what's the flavor size for the one you're going to choose. But by default, it's going to work because I know that I've chosen the one that have 6 gigs of RAM. So this is feasible for most of the simulators, unless they are something huge, which will require 8. The symptom, uh, if you choose the improper flavor, would be the booting, because when it's boot, it checks the RAM memory assignment, and if it feels like it's not enough during the loading of the elements of the node, like cards and etc., etc., they'll be having an issues with allocating into memory, and you will see inside of the log that it's rebooting, constantly rebooting. So while on the jump host and gonna ping the node and it's gonna respond with, for example, 4 pings, and then it's not responding, and then again 4 pings and it's not responding again, you can be sure that something is wrong with the node itself, and probably the flavor is not feasible. Okay, yes. So that's I think this is answer to your question. But
Yes,
by
yes.
by default, use the vSIM large. It's something that's gonna work, unless you use something like XRSs, or I don't know, SR14S, or something that is I would say the huge or big router itself. Okay, for the ones the small ones, for the 7th, for the 12s, or for the 1, 2, or 3, it doesn't really matter. This is just gonna be fine, the vSIM large. Okay,
May I have question?
yeah, of course.
Okay, regarding image, do we have latest image here available? It is 21 to R1. No. Okay, how
21
can
to
I install it?
in Pllamer, not because I need to put that inside and make a release. As I told you, that this is not implemented yet, the latest version. I haven't put that inside, so I'll be doing this after that session.
Okay, okay, please do it because this is used by our customer. Yeah, it is my goal to check this software exactly.
Okay, so if you could
21
be
or 20
if you could
R
be so kind,
3.
open a ticket. Let me just
Okay, okay, I will
uh,
open. Thanks.
for the purpose of this presentation, anything that is missing, just raise a request or raise a report issue. Whenever you want some additional software to be added, just open here, create an issue, put it with a minor priority, and put all the information inside. Okay, so that's gonna be helpful
Thank you.
because we are working in a team, and if I'm not available or I have not no access to my laptop, someone else is just gonna take that request and gonna be working on that. Okay, so we have 2 nodes. What can we do now? In the net functions, in the menu of the tools, you've got some few elements that can be used. Uh, the trick is that this Pllamer uses the right click button not as a menu for alternative menu or any kind of properties, but it's used for changing into select tool. If you press the right mouse button and slide it, you see that there is an area just to select the nodes. You can do it by this, or you can just press the first one with left key and control and press another and another, and you can select and unselect the nodes that you're willing to act on. Selecting two, let's choose simple connection, I mean line. what it does, it connects the first available port with the next first available port and creating a network. Let's take a look on the network itself. The network is created within a very simple way. It's IP address of 10, first IP address of the second, the second octet of the IP address is the ID of the first node. The third octet is the ID of the second node that is connected, and the last one is the ID of the node on which side it's created. So you can see that the network between node 1 and 2 is going to be 10, 1, 2, 0, /24, and first IP will be 1 and second will be 2, sorry. You can choose the ports to be connected with. The basic has the 4 ports. This is the limitation of the software, and this is not something that I'm limiting, but the virtual machines have only 4 ports. With the latest, I think they have 8, but I'm not sure. I would need to check the setup. Changing that will connect something that is called dummy network to the previous one, because the virtual simulators have it static, so there is no way of changing or creating anything else on or leaving that empty. If you change that, you can make a save, and that's all. Inside of the configuration, it doesn't really matter what IP you're going to use. This is only the IP network and subnet for the OpenStack, because OpenStack needs to create a subnet, need to create a network, need to create the ports, and those are the setup for this one, for the OpenStack operating system, I would say, because OpenStack can be called an operating system on the hypervisors. If you choose this one and go inside of your configuration and you change it to completely different IP address, once it's the same subnet and the same configuration for the network on the second end, they'll be reaching each other. They'll be seeing the packets. There is even possibility of connecting additional nodes inside of the one. That's something like a switch. And the switch feature is going to be presented in the next release of the Pllamer. That will be network that you can connect as many nodes as you'd like to. But for this is only peer-to-peer connections available for now. Okay, so once we have it, you just press export, hit template, and you've got simple configuration. Let me just show it here. You've got the simple configuration that contains all the necessary elements for creating like ports, like fabrics, like definition of the node with the basic setup and configuration of jump host. So this is the basic one. Okay, if you want to go back within the future, and if you want to choose something else, just save the JSON, and you can have the configuration of those nodes to be used in the future. So whenever I choose the open JSON and choose something that's was created in the past, I can just restore the setup, make some changes, and generate the heat template again. Okay, let's do something else. Let's say we want to choose the cards. Here we need to go back into the documentation. In the vSIM overview, there is a 2.2 section, which is the vSIM deployment models. There are two kinds of models that can be used. First one is integrated, which means that the node itself contains the card, but this is only visible in version 19.5 for C4, C12, SR1, and SR1S. All others requires to be a distributed deployment model. In version 16, however, the deployment model is for the same, but in some version of the TMOS, it's a change. You can see something more or something less, so it depends on the model. Pllamer does it and knows which version and which TMOS should be where. So as we have C12, and you can see that those nodes are as a default C12, just to be simple. Okay, let's go into something that requires the some distributed cards. So let's take a look. What can we do? Let's take SR7. Marek, could you remind me what kind of cards you wanted to use and what kind of chassis?
No, I'm looking just.
Okay. And as you can see, when I've changed the image to something that is latest, you could see the XRs as an addition, right? So 7250s that appear
Okay.
in the chassis.
I found in slot 1 card IOM.
But what was what's
Okay,
chassis?
chassis was SRI4. Possible? Okay, you have
A4, okay.
A4, not AR. 8.
And the second one was the same?
Doesn't matter. Yeah.
Okay, let's choose it. A4, save. So first one was this one, second this, okay. On R1, okay. Let's add the card. Was IOM A, right?
With MDAs.
With which MBA wanted to use?
A4-10 gig minus SSP. And A4 first.
This one?
Yes. And second MDA.
Okay, but hold on. Okay, this is something that I wanted to show you.
Support.
Whenever you see the element, the information that chassis type is not supported with this demos version and integrated model, means that we need to make some changes. Press OK, and then add this as a standalone to no, because we don't want to have it standalone, and we just want to be a distributed version. So once you choose the slot and cards, you need to remember that this needs to be changed. When it's added, you're gonna see additional node which is gonna be created. What are the cards in the distributed mode are the separate virtual machines with the same TMOS version running here, but the difference is once it's loaded, it doesn't gonna show you possibility to log into that. It's just gonna be connected with the fabric with the node that is connected as a card. So it's just gonna give all of the vCPU power and RAM into the operations of that card, like the real one, but it's connected with the proper port to the node that's gonna be acting and sending all the non-IP traffic between. So as you can see, the dotted connection means this is a card connected. Okay, we've got one card connected. For the second, let's do the same thing. Let's just maybe the same one. And add card, and you can see the additional card was created. So the most common problem and most common mistake made by the users is that once they have this, they connect those two networks with the single line. It doesn't make that work, because it's like we have connected cards in the one node and the second card in the second node. So if we want to connect ports on that card, we need to choose those, and with the net function add the single line, right? And you could see that we're gonna create a proper network between the nodes, and those nodes are connected here. So let's we've got the solution. If you want to have that more pure visually, you can hide cards. Hiding cards just gonna make that something to look like this. The gray network, it means that those are connected with some cards, and if you want to see the cards, just double click on the node and the cards will be visible again. Right? Double click on the nodes, unhide the card, and with the view hide the cards. So the logical connection will be something like this on ports on the nodes, and that's pretty much it. So okay, let's save the let's export the heat template. And here it is. And what it contains. It contains all the needed elements. It has the ports. You can see the network definition, network subnet of between the nodes, between the cards, the ports for that. And as you can see, the R1 is connected. It has a BOF port and BOF fabric. Second node has the same, right? And what's happening here? The card that's connected to the R1 as a distributed card is node 4, which has a connectivity to the BOF network, and the port fabric, which is connected to the proper subnet. And also the connectivity between the ports. So those 3 ports will be created on that node, and they'll be acting as elements. And you can see that inside of the user data, in the template, you have the proper chassis and the proper slot and card and etc., etc., which is needed to TMOS to boot. This is very crucial because every single mistake, like typo or misconfiguration, duplication of the element, can cause the node to reboot and not to work. There are so many elements that I have not tested all of them because it's almost impossible to check every single configuration. So once you see that there is a problem with loading and setting up the node, probably something is wrong here. And you can check by changing. And if you find a solution for that, if you could be so kind to tell me what was wrong, I would be very grateful and put changes and release the new version that will have all of those fixes. Basically, the Pllamer is the full of fixes for every single element that can be met inside of the or Nokia's virtual simulators, as they are so complex that there are no single solution for every single aspect. Okay, so let's go with that. Okay, let me save it again just to be sure that I'm okay. It's 85. Let's go to stacks. Let's launch the stack 85. Next, we need to put a name of a stack. Let's call it test 1 to 3. Here are the elements that are from the heat template. You can play with those, but if you want to work, I recommend not to. And just press launch. And if you have a required amount of resources in your project, you'll be able to create it. You can see that the create is in progress. Let's take a look what's inside, what's happening. As you can see, an OpenStack is trying to create. The gray blinking are the ones that are being created. The green are created at once, and the blinking the gray one are the ones that are in progress. So you can see all the resources, all the events that are happening at in that stack. During the creation, you can go into the instances of your project, and if it's all good, you should see in a while few nodes. It's just gonna be like 1, 2, 3, 4, and 5. We should see 5 elements. 1, 2, 3, 4, 5. Okay, they are in spawning, they are in build state, so they are not usable right now. Let's wait until the state changes. And as you can see, there are IP addresses and the networks being created as well. The jump host will have IP address that we want to access. from your laptop or whatever machine that you would like to use. We can start pinging just to see if it's running and if it's there. Okay, you can see it's responding, so the system is up. SSH as the root to that IP address, default Alcatel DC password, and we're in. Let's see if node R1 is reachable. Yeah, it is responding, and R2, both are responding. SSH admin at unless it's not responding again. Yes, and this is the example what I was telling to you. Probably there's something wrong with the elements of the node. Let's take a look what's happening. R1. Let's go into the router details. You can see it's responding again. Let's press the log. And it's not responding again. Yeah, so it's in the boot. It's rebooting again. We can find what's happening. Just wait for the log. Okay, and by pressing view full log, you can see the booting log of the node. It's starting elements. It's setting up here. Okay, there is a critical. The system configuration is missing or incomplete because on error while processing the configuration file. Okay. IOM VFP table allocation. So it looks like we have choose the or did something nasty to the configuration. Okay, let's go back to the Pllamer. The R1 is now as A8 with the version 20. I'm not sure if I have the documentation for that, but this should be proper as well. There's not many things changed. This is 19.5. It should be okay. Let's take a look on the appendix supported hardware. This one, and let's go down, scroll down to the A8. Okay, here we are. We have chosen IOM A card, and here's a CP. Okay, I think I know what's the issue here. Let's just check that again. Okay, I need to change that. As you can see, there is a problem. The Pllamer keeps adding this. I'll make a fix for that. On the card, you just need to choose the CPMA, and the slot should be empty, but the port on 4 should contains slot A. Yeah, this is proper for this one. This is okay, and let's check the R2. It's all right, and R1 is fine. Okay, so for some reason it got different configuration, right? And as I told you, whenever there is some even single sign that is unknown for the TMOS, it's just gonna crash and gonna boot. So this was a perfect presentation for what can be happening and why my stacks are not working, or what's the problem. This one should be pingable, and it is. So let's go here. And you can see that the second one that we choose was A4, and this is correct, right? And it's working. You might ask from where it's taking a configuration. Every single node with the basic configuration has the information that setup is being kept on some sort of FTP server that has the license file TIMOS and the primary config SR2 on the public folder of that FTP. The IP of that FTP is this one, 192.168.0.250. So it means that this is our jump host, and the jump host keeps the configuration files and the licenses. Licenses are being taken after the first start of this node. It's connecting to one of our servers and gets the latest file with the keys for the wildcards. Show system license. As you can see, this is a license for the wildcard, for the simulator, for the version 20, and it's information about the validity of that. So it's gonna be running for 110 days. Then we will refresh that. So from that point, show card. We should see that there is a IOM A, right? Let's go and configure card 1 info. Let's choose a card type. Let's go and take a look. There's MDA we have choose MA4 10 gig SFP plus. So let's configure that. Configure card it is already. MDA 1 MDA type and the one we've chosen. After a while it should change, and you can see it's down. Configure port. Sorry. My fluffy fingers. Four. No shut. You know what? Let's go here. And as you can see, the port 111 that we have connected between the nodes here, this one is connected and it's up. If the second one would be reachable and running, you could see that it's operable and it's fine. Okay, so let's do something more that you would probably use. Okay, we have that heat template 85 changed. Let's save it, and let's say there is an additional change that you want to have in your topology. I mean, you created few more nodes, but you don't want to touch those that are already created. What can you do? Inside of the OpenStack, you can go to the stacks, the orchestration stacks, and you can change the topology of your stack. How to do it? Change the stack template. You choose the file you want to change, and if the now OpenStack is gonna see what are the differences, and if there is something additional, it is gonna be added. If there is something missing, it's gonna remove, and if something is changed, it's gonna change. But if there is no changes on some of the nodes, it's not gonna touch. So sometimes it works, sometimes it doesn't. It depends on how much did you change, and is it possible for OpenStack to change it. Let's hope it's gonna be doable. Once it's changed, it's gonna reboot the nodes, add something else, and this is the way you can expand your topologies and make it works without changing the already working nodes. You can see we're still here. But R1 should be rebooting unless it doesn't feel the way. If it's not, we can just simply go remove the stack and create it again. Update is still in progress, so let's wait for that. Let's see what are the events. Okay, update in progress. A minute ago it's changed, so let's hope now R1 is going to be rebooted. I know it takes time, right? But this is, I think, if convenient for you just to have it running inside of the OpenStack because it gives you more possibilities of having a changes in here. Okay, so it's still running. Probably OpenStack does something in the background. If it's not, let's take a look on the log. Yeah, it's still running. Okay, not to waste the time. Let's go and rebuild that from the scratch. So what's I'm gonna do? I'm gonna remove this stack, 1 to 3, and create another one. Running from this one. Test 2, 3, 4, just to be different name. This one will disappear once it's removed, but not to waste time. Let's use the completely different name. Okay, so now it's gonna be frozen, right? This is something that we wanted to have. I'll just go here and start from this point. Okay, so the problem that we have was here. You press only on the one node. I've made a mistake. You press one node and add the card selected, and then you see the context menu of the proper cards that can be used. And remember, double click on the node will make it happen. Every single node needs to be created as it is. Okay, let me just see what's happening here. Okay, it's scheduling, it's building. You can see that all other nodes have been removed. This one is not reachable, so we don't use it. Okay. Okay, any questions so far?
Maciek, is it possible to modify the existing stack using Pllamer?
You mean reverse engineering, right? From the existing stack, just going back. It's not possible right now. I'm thinking of that kind of solution just to get all the information from the project, put it inside of the Pllamer to make it
exactly.
representation. That was one of the elements that we wanted to have before moving into the new Pllamer, but unfortunately, I didn't have the time to go and proceed with that. But yes, this is something that I'm having at the back of my head, just to select from the Pllamer existing project and create that in the Pllamer with the networks, with the topologies and all the connectivities inside.
Yeah, I think it will be very useful.
Mm-hmm.
Yeah, okay, thanks.
Okay, my question is, what was wrong in this file when you create from Pllamer?
Okay.
What was caused for not answering router? You
Yes.
remove some card definition, but I missed this part.
Okay, let me show you again. Every single configuration that is created as a heat template has some elements inside of the. Let's take a look at the R2. R2 is containing it contains all the information for the OpenStack, like flavor, images, networks, as well as the user data. The user data and the template here, and the parameters from this get attributes are being pushed and injected into the virtual machine that keeps the TMOS running. And only at the first boot and creation of that node, the TMOS gets all of the elements and put inside of the BOF configuration. If it's empty, it's going to use the default configuration, and if it's somehow filled in, it's just going to use that. What we were missing, we had something like this: C12, slot A, card, SFM, XP, and then we have MDA, which in our example was, sorry, no, this is not the proper file. Let me just, yeah, this is the one. As you can see, I'll just redo. Yeah, we've got the definition of the CPM of the main node with the MDA configured. And for, as you know, on the CPM, you cannot have the MDA installed, right? So that was faulty. And this is, the TMOS virtual machine does not act properly with something that is not regular, unknown, or misconfigured. So whenever you put, that might be informational for you, right? But I could even, for the TMOS, in that context, it would be even equal to A, B, C, D, right? If you put something like this, the TMOS won't understand what it is, and will just, for the prevention, it's just going to reboot itself, saying maybe in the next time I'll get the proper configuration, but it was not. So if you have the CPM cards, you need to keep it empty with the space at the end, and all the configuration needs to be done on the cards that are inserted, right? So the cards, as you can see, have the slot 1, card, and MDA. But for the CPM, it doesn't need, and it doesn't allow you to have anything additional. So this was the problem. I think it was because previously I've chosen a different card and it was stuck somewhere else inside. This is not a perfect tool. This is not 100 pure without any bugs. It gives you possibilities of changing everything, because I think this is a need for engineers, right? Just to have a possibility to use it in the way that I would never dream of. And it's not foolproof. It's just for you guys, just for the engineers that can do whatever they want without any limitations. So that's why I'm sometimes I don't fix those, because some of the errors are not the errors, but features that you can change anything, make it break, and choose whatever you want. Okay, let's take a look on this one. It's running again. It has a completely different IP address. Okay, let's change with you this one. Okay, let's SSH into the first one. Oh, and this one has it didn't get the license. Well, let's take a look on the second one. Yeah, this guy's the same. What happened here? If you log in into the node, and you can see that you cannot make any additional activities around, only show system and show license, means that something's wrong with the licensing, and they didn't got the license proper. It can mean two things: that the jump host was started later than the nodes itself, or the licenses are not proper there. What you can check and what you can do: As I told you, the jump host is getting all of the licenses from the server. Inside of the jump host, and we have something like the service. It's called keys, and if you do systemctl restart keys, you should see in the status that it downloaded the files, and there should be a var ftp pub, sorry, cd less, and you should see that the file Timos is from now. It's 3:55. It's the Canadian time, but it's 6 hours before, so it's 9:55. So it's latest. What can we do now? Now we should hard reboot instances. I mean, every single instance that needs a licensing needs to be rebooted. I've rebooted number 2.
By the way, what is the difference between soft reboot, hard reboot?
In OpenStack, the soft reboot sends information to the system itself to gently try to reboot, but the problem is that sometimes it doesn't work, and it waits some time and then tries to reboot. The most common issue that we have is that users choose the soft reboot and then have a problem with the disk, because in the middle of read and write to the disk, the OpenStack goes like it's timeout and I'm shutting down the virtual machine or restarting. The hard reboot is just like unplugging cable and plugging again. Remember that the seams are nested on the sys Linux, which is the very small Linux that contains all the needed elements. And the main difference is like this, right? So the soft reboot sends information into the system and thinks that it's working, but it's very dangerous inside of the OpenStack. For me, I think hard reboot is the most. It sounds it's not, but it's I think it's more gentle way of rebooting the nodes. And hard reboot is just
Okay.
like powering off instantly with like you would just take out the plug from the node.
Yeah. Okay. Thanks.
Okay, so R2 is booting. Let's take a look if it's pingable. This one is still not. This one is responding. Okay, let's try. If you see something like this, it means that the key was changed, and the only way is to remove those keys from our list. And you can see it has a configuration, right? You can see the cards. So let's do quickly configure card 1, configure card 1, info card type, IOM, MDA 1, MDA, I don't remember, show MDA. Okay, configure, we have MDA 1 and MDA type. Okay, port is up, port is there. Configure port 1114, no shut. Show port 111 is up. Okay, let's leave it as it is. Now let's, what was the IP address of the node? I'll use this one. No. Okay. Let's go to jump host to configure the first one, R1. Okay, show card, show MDA. First I need to configure the card. Okay, configure card 1, card type IOM-A, show MDA, configure card 1, MDA 1, MDA type, show port. All right. I'm shutting all of the ports on purpose, just to show you that it's connected to the one that we choose, not the one next one or another. And as you can see, it's there. So let's do interface. Configure interface. So router interface. Let's call it R2 port 111. Address right. It's up and operational. Let's do the same here to R1.
The subnet doesn't need to match the ones created in OpenStack.
It doesn't, but I'm using it just not to think as something else, and it's just a habit of mine, just of using that. But if you if you want, we can change it, and it should go. And I will show you what's inside, how it works. Okay, just let me configure this one. 224. Show interface. Oh, show not the interface. You can see it's up, and let's ping the first one. Ping 10 1 2 1, and as you can see, it's responding, right? So the network works. Okay, let's go into the R1, for example. Something that can be useful for you guys is something that with Krzysztof Dolek we have created. We have added possibility of using the same feature like in GNS or other simulators. It's a Wireshark. Okay, you can see that on R1 we got interface fabric and BOFnet, so it's not for us. But let's go into the card of the one of the port of the nodes, sorry, and we want to listen what's happening here. And as you can see, I've got node, but there is no port or network 10.1.2 subnet. Instead, it's 454. But from the drawing, we know that this is something here, right? So this is the connectivity between node 4 and 5. Okay, let's go here, and you can see if you install the Plink. Plink is the simple node, a simple program from the guy that was creating the PuTTY. Let's try to start. Yes. Okay. There is a small change. If you have any issues, try to take a look here, and we can see that we have that kind of error. Data written pipe is not, and we need to do -batch. Okay, so we will turn off this. We will stop here, and we need to change that. This is the issue with the latest version that I have installed. So here's the information what needs to be done. This is for the previous one, and the latest versions of the program should contain batch, and it works. Okay, you can see that it's quiet here. Let's try to ping, and you can see that the ping is going right. Source, destination, ping request, reply. It was working. I can try to ping something else like 5, which is there is no such node, and we should see the packets, right? You can see who has, and the node 2 is asking. So fully working Wireshark for the needs of any activities around that. Okay, guys, I know that we have this meeting a little bit longer that we've planned, but I hope this is something that can be helpful for you. Any questions? Any thoughts? Comments? Marek,
No, right
does
now,
it
thank you.
fits your needs, or was it this one that wanted to be shown, or?
Yes, of course. It's perfectly prepared, but we have to train. Yeah, we have to
Yeah, this is
try that
definitely
ourselves.
need to spend
There's a
some
lot of
time.
information. I hope you put your recording somewhere to check again. Yeah, to look at it.
Of course, I will.
Okay.
Arek, I'm sorry. I know that you have been asking something.
No, just said that no questions right now. Thank you.
Okay, guys. So I think that that's gonna be it. I'll post that recording for you just to watch it again and make a use of that.
Thank you very much.
Thank you so much and have a great day.
Bye bye.
Thank you, Matthew. Cheers. Bye.
Thank you.
Bye bye.
Cześć.
Bye.
Bye.